Welcome, everybody. We've got quite a few people on Zoom. We invited a few other Oregon clubs to this Zoom call. Tonight, we've got a very special guest. We've got Randy Oliver. He's going to talk about reading the combs, understanding bee biology over the course of the season. Randy's a lifelong beekeeper, researcher, educator with 5 decades of experience in apiculture, and widely known for his applied research on honeybee health and practical solutions to modern beekeeping challenges. And Randy, I'm going to turn it over to you.
Okay, doke. Yeah, I had 4 different research projects going on today and preparing 2 other ones. So it's been a busy day. And suddenly I remembered, oh my gosh, I got to come in from the lab and talk to you guys. So I'm here. I'm going to go ahead and share my screen right now. And okay, this one and share. And I'm going to go to slideshow. And from current slide, hide these things. Great. All right. Can you see my my slideshow?
Yes, sir.
Great. Okay. So let me go ahead and start ahead here. So one of the things with beekeeping, it used to be simple. When you got your first beehive, you got a little skinny book about 8 cents thick, first lessons in beekeeping, and that was it. And it was just really simple keeping bees alive. Now with the advent of the internet, you can go crazy with all the different conflicting advice that you get. And I really feel that beekeeping is as simple as it ever was, other than varroa management. And even that's pretty simple. So rather than from a human perspective, let me go over the rules of beekeeping from the bee's point of view, from as far as the human bee husbandry, how we can help the bees. First thing, they need a warm, dry cavity. They typically nest in a hollow tree cavity. Any wooden or otherwise waterproof and windproof box or cavity works just fine for them. They don't really care if you got a Langstroth hive or a Warrior hive or a top bar hive or a styrofoam hive or anything else. But as long as it keeps the wind and rain out of it, they're fine with that. So from a husbandry standpoint, very easy for us to provide them what they need. But by the way, going back on for wintering, I'm finding that the calls for high levels of insulation are overblown. I'm seeing something's even an R4 insulation, a little better in a cold weather, very cold weather than a 3/4 inch wood, but it does not have to be excessive at all. The second thing they need is food and nectar. That comes pollen and nectar coming from flowers. So you have some options to help your bees out. One, live somewhere where the flowers bloom all the time. If they're not, the bees aren't dormant due to the cold. The second thing, to move them as a migratory beekeeper to the bloom, or you can supplemental feed them. If they don't have enough food stores and there's a dearth, they may need a little bit of sugar syrup to get through. Maybe some pollen sub if you live in an area like I do, where there's almost no late summer and autumn pollen flow. Other than that, in many areas, they don't need any food or nectar at all from the beekeeper, as long as they leave enough honey on them to get through the winter. Then the third thing, rule, is they need to manage their parasites. Every species on Earth has parasites. We humans have parasitic mice that live in our hair follicles, and we deal with them. And the honeybees deal with most of their parasites pretty well, other than recently introduced parasites. So when the tracheal mite was introduced, it was tough. Wiped out 70% of the bees in California when it invaded. It was awful. Nosema ceranae invaded. We had CCD for several years until the non-resistant bees were all weeded away from it. This last parasite that we've gotten, the varroa mite, we have prolonged our agony for many years by totally counting on synthetic miticides to control it, rather than selective breeding for resistance to it. So I'm writing about that subject a lot right now. And until we all keep bees that are naturally resistant to varroa mite, and from a husbandry standpoint, it behooves us, is our ethical responsibility, to help the bees if you don't have a naturally resistant stock to control the varroa mite. That's it. End rules. If you didn't get them all, it's really simple. Warm, dry cavity, they need food, they need to control varroa. Other than that, anybody who tells you what you need to do for beekeeping, that's a reflection of that person rather than from what the bees actually need. So my suggestions to you for beekeeping is first, practice basic animal husbandry. If you have kept any other kind of livestock, feeding and sheltering them, the same rules apply to honeybees. The second thing is copy consistently successful local beekeepers. You guys, you up in Oregon, don't be looking on how we keep bees in Southern California, how you keep bees in New York, or how you keep bees in the Midwest. Look at the local beekeepers. Now, consistently successful does not mean the loudest beekeeper or the necessary the president of the club. No offense, Brian. But it means the way you can tell a consistently successful beekeeper is their biggest problem is every spring they've got too damn many bees and they have to get rid of them. Otherwise, they're all going to be lost to swarming. Any beekeeper that's buying bees is not successful. Okay, success is indicated by your colony numbers are going to double every spring by natural reproduction. So that's the way I would look for consistently successful local beekeepers. The other thing to do with the commercial beekeepers, look for those that drive new trucks. If they're not making money, they're not being successful. Okay. And I love this quote from back in 1920 from Theodore Edwards, that the bees have their definite plan for life, perfected through countless ages, and nothing you can do will ever turn them from it. Understand that you're not going to ever change bee behavior in any way. You can delay their work, or you can even thwart it altogether. But no one has ever succeeded in changing a single principle in bee life. So accept that fact and realize that you are a servant to the bees as a beekeeper. And he says, so the best bee master is always the one who most exactly obeys the orders from the hive. So to obey the orders from the hive, learn how to see what the bees are telling you, what they need. And that's why I call this reading the comb. So base your management decisions not upon what somebody else is telling you to do, but what you see with your own eyes when you open up the hive. So the first thing is to understand the ecological niche of the honeybee. Now, an ecological niche in human terms is called a business model. Every organism on Earth has a business model. Where they live, how they eat, how they deal with their enemies. That's the ecological niche. So understand the business model of the honeybee, of the superorganism, the honeybee. It has two main objectives. One is it's the only one of the very few insects that maintains an elevated body temperature during the winter. To do that, it stores honey to have food supplies during dearths and during cold periods. So that's number one objective. They're called honeybees because they store all this food above the brood nest in their cavity for food reserves. From a human perspective, a beekeeping perspective, we want them to do that. So we work in collaboration with the bees in order to help them make their life as easy as possible so they can store more honey than they need so we can harvest that surplus honey. The second objective for the honeybee is to propagate its genetics. Once it has filled this cavity with food reserves, it's got nothing else to do but reproduce. So it will just keep swarming as long as it can until it has not filled the cavity or until the nectar flow and honey flow stop. That is contrary to what the beekeeper generally wants. You don't want your colonies to swarm. So we'll talk about that problem we have of balancing those two things later on. So I've drawn the honeybee population in the black curve here over 3 seasons. Notice that I don't put in any dates at all. It has nothing to do with daylight. It has nothing to do with month like that. It has totally only to do with nectar and pollen availability. And this became very clear to me when I was in Australia on the winter solstice, the shortest day of the year, and the bees were on a full nectar and pollen flow, brooded up to the max and putting on honey on the shortest day of the year. It has nothing to do with daylight. It has to do with food availability. When food, now this I just put on a typical nectar and pollen flow based upon the curve for my area in Northern California. When the nectar and pollen starts coming in the late winter, early springtime, the colony goes into buildup mode and it increases the population up until it gets tops out on brood rearing, and the brood rearing plateaus, usually around 2/3 of its ultimate strength. And at that point, it goes into reproduction mode prior to the food storage mode. They want to reproduce so that their swarms have a chance of gathering enough stores to put on stores to make it through the winter. Then they shift to food storage mode, deprioritize brood rearing, and put on as much honey as they possibly can, pack it away, until they go into dearth mode, at which point they want to decrease the number of mouths to feed and go into the survival mode, whether or not there is cold or not. So in Mexico, this begins in November. That's springtime because that is when it starts raining and the flowers start blooming. Then the dearth mode begins in July when it gets dry, and July through September is dearth mode. Then it's not during the shortest days of the year. It's when there's no flowers blooming. And then they repeat this again. So forget calendar dates. Look at the nectar and pollen availability. The cluster moves like a yo-yo. So in this tree cavity, when they are storing honey from excess nectar, more than they need, they put it above the brood nest and force the brood nest down to the bottom of the cavity. When there's no nectar coming in, they eat their way up into there. And the whole point is they don't want to ever hit the top. If they hit the top and run out of honey, they will starve to death during the dearth. So that's the yo-yo effect of the bee colony moving. Now, everybody loves a picture of a nice fat queen bee. I call it beekeeper pornography. We can look at pictures of queen bees all day. But the queen bee is the only normal female bee in the hive. She's a normal egg-laying, fertile Hymenoptera female. The special bees in the hive are all these sterile workers, all these sisters that do all the work in the hive. The queen is simply the ovary, the egg-laying machine. She also secretes some pheromones that regulate colony homeostasis, kind of the pheromonal heart of the colony. But she doesn't tell anybody what to do, make any rules, and doesn't even, has very little to do other than putting out some pheromones and laying eggs. The bees that run the show are those that control the food supply, and that's the nurse bees. They respond to environmental cues to decide whether the colony is going to be in buildup mode or in survival mode, whether or not they want to feed the larvae that emerge from these eggs, or even to allow the eggs to exist, or whether they will just cannibalize them and recycle the protein. So the nurse bees control everything in the hive. And you can tell it very easily if you're doing a squash for nosema. If you get nurse bees from the brood nest and you squash them, the water will turn yellow or orange from all the pollen in their guts. If you take foragers from the entrance, there's no pollen in their guts. They lose the ability to even digest pollen when they mature into foraging. So they don't eat any pollen at all. They want protein. They got to beg it from some nurse bees. And the foragers do need to do that to maintain their wing muscles, beg protein from the nurse bees. The nurses then do this process called trophallaxis, where they transfer jelly from bee to bee. So that's like a communal stomach in the hive. Every bee in the hive knows the nutritional status of the hive because they are always begging each other for jelly. And if the nurse bees go, oh, sorry, dude, don't have anything to spare, then all the forager bees know, wow, we are in starvation mode or poor nutrition mode. We better go out and forage for pollen or for nectar. So everybody is always informed of the status in the hive. And if they're going to starve, they all starve as one. It's not like a few bees starve first. The whole colony goes into starvation at the same time. Now, jelly is what the nurse bees produce. They have two glands in their heads, the pharyngeal and a mandibular and the hypopharyngeal gland, and they add nectar to that. And those three components gel when they get mixed in their mouth and come out in what we call jelly or royal jelly. The three components are the same. They're just in different proportions. That worker jelly and royal jelly are essentially the same. But it's a perfect feed for honeybee. It's very similar to the way mother's milk is the perfect feed for human babies. But it's way better than mother's milk. If you had a honeybee only grows the larva for 5 days, 5 instars, 5 days of feeding, and they go from the egg to the adult size. if they start at the size of a human baby, 7-pound human baby on day 1, by day 5, they would be the size of a 4-ton elephant. That is how fast honeybees can grow on this perfect food, the jelly that is fed. Now understand the dynamics of the hive population. You have recruitment of new bees versus attrition of the older bees. So this is the way the colonies deal with any kind of problem. They get a pesticide kill, they get a weather loss, they get a parasite kill, bacterial kill, whatever it is. They just try to rear more replacements to make up for the fallen soldiers. That is the recruitment. Attrition is, most of it is just a natural aging out of the wing muscles of the foragers. The forager bee can only fly on average for about 12 days or so. So after 2 weeks of flight, very few foragers live. So the bee lives first part of its life, first several weeks, as a nurse bee and a mid-age bee. Once they start foraging, they are very limited lifespan at that point. There's also loss from weather and them just getting lost, predation, some disease. Bees will, if they start to feel sick, they fly out and do not return. So if you artificially inject substances into a bee that, without sickening them at all, make them think that they're feeling sick or that their immune system ramped up, they will just fly out and not come back to the hive. Now here's the balance of recruitment versus attrition. So here's the normal growth curve from 10,000 bees in a hive up to 50,000 bees. And I put in the net gain or loss of workers per day. This is per day. So during buildup mode, you get a net gain of about 500 bees per day. Now this is net. So if that queen is laying 1,500 eggs a day, you subtract the 500 from that, and that means that 1,000 bees are dying of old age every day during rapid buildup mode. So any of you who are hesitant to sacrifice 300 bees to do a mite wash to save your colony from dying, realize there's 1,000 bees a day dying of old age during this time of year by themselves. Finally, it comes into equilibrium, the recruitment rate and the attrition rate, and the colony population settles out. After that point, then they want to reduce the amount of mouths to feed, and during dearth and attrition exceeds recruitment by typically a lower rate because the queen is slowing down on egg laying, or the nurses are on recruitment, and the colony population drops back down. So we can look at the colony age structure over the course of a year. This is data from Lloyd Harris's thesis, and I colorized it. That shows the amount of brood in the hive. This is eggs, larvae, and pupae. And the amount of adult bees would be the top of the colored curve. Notice that during the spring turnover, you have more immature bees than you have emerged adult bees. You have 2 to 3 times as many immatures as you have adults. We get back to that later on. And I color coded this, that bees, adult bees from 0 to 12 days old are in the red. Those 13 to 24 days are in the orange, 25 to 36 in the light orange, and very few bees make it past 48 days during the spring or summertime. We'll get back to this. They do live longer during the dearth period. So I realized years ago when I wrote a series it's on my website called Understanding Colony Buildup and Decline. And there's different biological phases they go through. And I'm going to go through all these phases kind of quickly over the course of a year right here. So the first thing to do is understand what the bees are exposed to as far as food in your environment. So I recommend every club makes a phenological table. Phenological means based not upon date, but upon what is blooming. So make a list of all your bee attractive plants in your area, and then put them on a calendar. And this is, of course, where I live, you drive 5 miles and you may be 1,000 feet different in elevation or more. So it changes. It can be a month difference by driving a bit. So don't even worry about the dates. Just do phenological, just the plants. And then put on what your colony population is, how many combs of bees there typically are. Put in when they typically swarm. Put in when your main honey flow is. If you have any toxic plants that bloom, we have a California buckeye down here. When there's a dearth. And then this will help everybody make their plan, and you count backwards for everything to do for management from the plan on the technological table. Over that, you now overlay all your main management things. And this is on my first year beekeeping website, web page. Take a look at it. And when they might need some extra protein or syrup, when you look out for European foulbrood, when to deal with Varroa, when to make sure they're ready for the winter. So everything, again, understand this timing and then count backwards from that to make your management decisions. So, and my suggestion is, don't think about what the books or the internet, what anybody tells you. Base your management decisions based upon what you can see the biological needs of the colonies are by simply looking at a comb from the middle of the brood nest, something like this comb right here. The second thing is, before Varroa arrived, my advice to people was, if you don't know what you're doing, don't do anything. Just leave the bees alone. They've been doing this for a long time without any help. Just give them a box and they'll be fine. Once Varroa arrived, yeah, you do need to do Varroa management, but in general, if before you ever open the lid to a hive, have a plan. Know what it is you're looking for and what you're going to do if you see that. Don't just go in there and start fumbling around, but know what you're actually going to be doing and understand why you're going to be doing it. Not just because somebody told you, because I hear all this advice of people saying, oh, well, somebody said to do this. I said, well, why? Why did you do it? Well, I don't know why I did it. Somebody told me to do it. So understand the why and learn how to look at the combs and read them. So the things you want to assess is first the honey. Right near here, you can see this is older honey because the cappings have, the airspace has dissipated and the cappings have touched the honeys. That means this is older honey. If it's white, that means it's fresh honey. Then you have fresh pollen coming in, which is dull colored because it hasn't been fermented yet. And then bee bread would be surplus that is fermented here and usually a shiny color. Then you have the nurse bees right here. These are the ones that are consuming any of the pollen right here. Open brood is the larvae and eggs that you see here. And then sealed brood, which is also known as Varroa food. This is where Varroa is reproducing. And some of you will be better Varroa keepers than you will be beekeepers. So understand you have two animals in here in this box that are always going to be there and always going to be reproducing. Now the question is, how do the nurse bees know what's happening outside? Because the nurse bees don't fly outside. It's maybe just to poop very briefly. This is what it looks like inside the hive. Bees live most of their lives in total darkness and only go outside and fly for about 2 weeks. So forget your whole human perception of what it's like to be a honeybee. The bees do not depend upon vision at all until they become foragers. Up to that point, everything is done by smell mostly, and touch and taste, but mostly the sense of smell. So the nurse bees, in order to make their decisions on whether to cannibalize the larvae or to feed the larvae, whether to feed the queen in excess so that she can lay eggs or to cut back on the feeding to the queen, they look for these cues. First, the incoming nectar. That means tells them that flowers are blooming. They look for incoming pollen. That means, hey, there's enough protein to go into buildup mode. If there's no pollen, they're not going to go in, no fresh pollen. They're not going to go into buildup mode. And then the young larval pheromone, the E beta ocimene, put out by the very young larvae, tells every bee in the whole hive, hey, we are in buildup mode. We have the young larvae putting out this pheromone. That tells the foragers, tells everybody in the hive what the mode that they are in. There's also some other pheromones involved in the pushing by the emerging workers, the older bees off the combs. But these are the main cues right here. So any stored bee bread that you see around underneath the honey band at the top, that's a surplus. Okay, this is not stimulatory. This is a stimulatory to the nurse bees, as that cupboard you have off the side of the kitchen with all that canned food you've had in there for 10 years, but survival food, that is not stimulatory to you at all. And this is not stimulatory to the nurses. This is survival food. The stimulatory pollen is put right here fresh, right in. As soon as a worker bee emerges, they fill these combs here. You don't see this much because it's immediately consumed by the nurse bees. There's a huge turnover of this pollen, but this is the pollen that stimulates the nurses to produce jelly and feed the larvae. Another picture here. Look at this. No bee bread out here at all. This is the stimulatory pollen. It's this place right next to these larvae. So these nurses, they're feeding this larva, they turn around, they get a meal of jelly, and they turn right around and they feed the nurses and they transfer a nectar. So this is what puts the bees into buildup mode. You can go into winter with a ton of stored bee bread, and the bees are not in buildup mode because that's not incoming pollen. So pay attention to this interface, the interface between the honey and the brood. Now this honey is fresh honey. You still have white air under the cappings, okay? So this was recently put on. You got a little bit of bee bread right here, so they have a slight reserve. This may be gone by morning. And then here is your brood right here. So this interface between the honey and the brood is what you want to look for. What you have is your energy stores right here and your protein reserve. So this is stuff to get them through dearth periods. Down here, they are rearing brood. So this is your energy and protein demand right here. So here's the demand, here's the reserves. The two interfaces are the energy interface and the protein interface. Energy interface occurs right here, right at the edge. You usually have one row of open cells between the honey and any bee bread. And it's either going to be uncapped honey, which means it doesn't shake out of the combs, or it's going to be fresh nectar being converted into honey, and you're going to have the brood nest being pushed down. So you're going to check this out by putting a stick in it or shaking it to see which one it is, whether they're eating their way up or pushing their way down. Then the protein interface is what's between any stored the honey and the brood. So here we have, this is where this means the nurse bees are not eating this protein at all. The interface is right here at the edge. So they're eating all the bee bread stored here every day, every hour. And this is all they did. So that means you have a surplus beyond the protein interface. So let's go through the year. First cue to the nurse bees of incoming pollen. For us in the Sierra Nevada, it's the alder bloom, which happens early in January. And that kicks everything into gear. Same thing up in Manitoba, Canada, with Lois data. That started in March, and you see there was very little brood rearing during the winter, and bingo, they take off and start rearing their brood. So this is a picture from my area with alder pollen just pouring in. That means that during January, we had warm flight weather, and the bees do great. Unfortunately, it often rains during alder bloom. And forget what you read in the books that tree pollens are not nutritious. You get beautiful brood on the alder pollen on these colonies. This means the game is on. That means that the nurses are going to start pumping extra jelly to the queen to stimulate her ovaries to develop, and all the eggs that she lays, they are going to feed and produce jelly for them. So we can see fresh incoming pollen right here. And this young brood pheromone then puts the whole colony into buildup mode. As soon as the bees start smelling this young brood pheromone, every forager knows, hey, we're in buildup mode. Get our asses in here and get out there and start bringing in pollen to feed the nurse bees. Then we go into the spring turnover. So we can see almost no winter mortality of these bees right here. But then once the first pollen starts coming in, these bees go into nursing mode now, and they're going to be nurse bees for three weeks. After 3 weeks, then those young bees emerge, and about a week later, they start pushing the nurse bees out and for them to become foragers. As soon as they become foragers, look at what mortality. Again, they're only going to forage for about 2 weeks and die off. So this is what happens. It's a delay. You got about a month from when they start brood rearing until all these old diutinus or winter bees, which is just arrested nurse development, they start foraging, and at that point they very quickly disappear from the hive, being replaced by the younger bees now, a whole turnover. So they go from the very old age bees to a colony full of young bees. And at this point, again, what I said, you have more brood than adults right now. Now, if you just happen to have a strong bloom at that time, then these bees will suddenly start, every bee other than those acting as nurses will immediately start foraging, and the colonies actually can sometimes collapse. We see this in almonds sometimes because they don't have enough brood already in sealed brood ready to emerge, take the place of those. So you want to build your colonies up before you go to almond bloom. Make sure they have plenty of sealed brood before they get into the almonds. And here's a typical colony. This is in late January in my area. You see some alder pollen right here. Beautiful brood pattern. But these are the bees that have lived through the winter, the winter bees, waiting for this brood to emerge to take their places. And this is where you start getting problems with some of the parasites. Now, viruses are parasites, bacteria are parasites, mites are parasites. They're all parasites. And again, we're going to go through the seasons here. In the during early buildup, when it's cool, European foul brood and shock brood are prevalent. You don't see them much the rest of the year. You're going to see a lot of nosema anytime there's a bunch of pollen coming in. That doesn't mean it's necessarily a problem, but nosema proliferates when there's fresh pollen in the bee's guts. When the pollen flow drops off, nosema pretty much disappears. Varroa and deforming virus are problems later in the summer, late summer and fall. And then during the winter, the paralytic viruses, when the bees are a bit stressed by cold, can be problematic. Now, nosema, here's a 400 times magnification picture with the bee's tracheal tube. There's striations in the gut tissue right here. This is midgut right here. And every one of these little white ovals is a nosema spore from Nosema ceranae, just completely filling the gut tissue. So a badly infected bee like this is a problem for this bee. But normally, you only have a very low percentage of your bees in the hive that look like this. Now, during CCD, what we saw is this. You pull out a comb like this in late January, look at that beautiful brood pattern. And I would say, oh shit, this colony is about to collapse. I just told you it was late January, which means we have cold nights. There's no way in the world that many adult bees get that much brood warm on a cold night. This means that we have higher attrition than we have recruitment, that these bees will not be able to keep this brood warm on a cold night. So we have one cold night and the colony looks like this the next day. So those bees had clustered down, and this was due to Nosema ceranae, which was a problem in the early 2000s. And then during the day after the cold night, they clean out all that chilled brood that they were not able to keep warm. But you can see the band of bee bread here. That's how big that brood nest was a day or two before. So this kind of collapse is very common during that CCD epidemic in the 2000s. We don't see this hardly anymore. Now, another misconception many beekeepers have is that dysentery indicates nosema. There is zero evidence that either of the strains of nosema, the Apis or the ceranae, have ever caused dysentery, and lots of evidence that they have never caused dysentery. Dysentery is due to a water imbalance or poorly digested food. And the bees want to fly out to defecate and they just can't hold it. As soon as they get out the door, they squirt it out. Now, if they defecate within the hive and one is infected with nosema, it can spread spores, but nosema does not cause this. This does not mean a colony has nosema. Nosema can only be diagnosed with a microscope. So here's pollen grain, bee hair. These are Nosema ceranae spores here. And nosema is kind of an enigma. It really does not normally have much of an effect on a well-nourished colony with a young queen. But if it's prevalent, if you get more than half the bees in the hive infected by it, then the colony will really slow down. And you get like 8 out of 10, they can collapse. But we don't see that much to any extent. This happened a lot during the early 2000s. Now, once you get past the spring turnover, the bees go into the linear growth phase, as long as there's pollen coming in. This data from Nolan from 1932, where he studied package bee buildup. He started 4 weeks after the package installed, when the bees started to emerge, and they had a brood nest right here. And he gets this straight linear buildup of the colony until you reach the equilibrium, where the birth rate comes in equilibrium with the attrition rate. And that's about 40 times the recruitment rate. So 40 times. Now the queen, let's just say that every egg she lays gets fed by the nurse bees. So the queen's laying 1,000 eggs a day. The colony population will top out about 40,000 bees. She's laying 1,500 eggs a day. You got colonies up to 60,000 bees. So all these colonies top out when you reach that equilibrium right there. And 40,000 bees is a double deep, full of bees. Okay, 60,000, you need a triple with the bees packed in it. And again, Roy's colonies grew linearly right here. Now, these colonies can grow very fast and live hand to mouth. They are very much in danger of starvation right here. And you have this, again, you had 1,000 bees a day dying from old age. So this is almost a complete turnover of your workers about every 6 weeks. That requires about 2 pounds of pollen coming in each week just to get the protein to replace these workers. So here's a colony expanding up into its honey stores to build up in the springtime, living pretty much hand to mouth, just enough nectar coming in. And by morning, all this bee bread here might be eaten, but they're in full build-up mode, and then it rains. Dr. Karl Krillsheim in Germany did experiments where he put sprinklers over the tops of hives and observed the behavior of the nurse bees. Within 45 minutes of turning on a sprinkler, the nurse bees started cutting back on the amount of jelly that they fed to the larvae. So the nurse bees are, even though they don't go outside, they know what's happening because suddenly the pollen flow stopped coming in. So colonies respond very quickly to a cessation of the pollen flow. And when I plotted out Lori's data, I wondered what happened right here, why we had a decrease in the amount of brood. So I looked up weather history for 1976 from Manitoba, Canada. And sure enough, this is when a cold wind and a snowstorm moved in during buildup mode, and the colonies cannibalized the brood right here and then recovered once the weather changed. This is my sons here in the Grass Valley area. We got hit by a surprise snowstorm late one April after we had already put the second boxes on. The colonies were building up. So of course, I tell the boys, put on your gear. We're going to go out and take care of our bees. We are the only beekeepers in our town that did not lose all their colonies. Everybody else's colonies suddenly starved to death. This was taken 4 days after the beginning of honey of that storm, and they'd eaten all their honey, eaten all the bee bread, cannibalized all their unsealed brood right here. Yeah, it was amazing. So unless you were out there taking care of your bees during that surprise storm, every colony died other than ours. We're also seeing sometimes even as climate changes here, yards where we've put bees out for 35 years, nukes during the springtime, and always have plenty to eat. We walk out and wow, even though it's been spring weather, we'll see dying bees because they're expanding the brood nest so fast, and the plants that we counted on to supply nectar did not happen. So we're having to actually start feeding nukes in yards that we never had to feed them in before. Now, this did not kill the whole colony. Just they kicked out the bees that died, and there was enough when the flowers started blooming to let them recover. But this is a new phenomenon for us. And yes, if your bees starve, it is your fault. And yeah, it's very easy. All they need is some sugar in any form, whether it's liquid, fondant, even just granulated sugar poured over the top of them, a comb of honey. We've saved colonies with a can of Coca-Cola before. Any kind of sugar is all they need to prevent starvation. Here I am treating my bees better than I treat my own children. My sons grew up when it was rainy and miserable, we'd be out feeding our bees. And people say, well, Mandy, you're out feeding your bees when it's raining and snowing? I go, well, duh, when it's warm and sunny, they take care of themselves. That's your job if you're a beekeeper. If your livestock is going hungry, that's your job as for animal husbandry to take care of them. Not just feeding them protein, but nectar. When it's raining, bees can't forage for water. So they can get, if they have brood, they get very thirsty during a rainstorm. So during rain, we will feed them a light syrup with that protein so they can make enough jelly to feed that brood. So you're creating an artificial nectar flow here. So understand this. When it's raining, the colony, if it's in buildup mode, will get very thirsty despite it's raining because they do not forage for water there. So it stops raining, they're going to forage for water at their normal water holes. Okay, hive inspection. Okay, as a professional beekeeper, you yank one comb out of the middle of the upper brood nest, and that's pretty much all you normally see. I take one glance at this, go, wow, adequate honey reserves, adequate bee bread reserves, good larval survival, they're clean right, bingo, close it up, 15-second inspection. That's all all I would need to do. This would tell me everything I needed to know about that colony. This is healthy brood, meaning good larval survival because it's all even aged. Spotty brood, if it's springtime, this usually is a sign of European foul brood. And I'm sorry, in late summer, this would be a sign of brood cannibalism. So this could be healthy in August in my area. This would be a healthy colony. What you want to look for is your larval age progression. The queen usually starts in the middle and goes round and round laying eggs. And then when the eggs emerge, the larvae grow. So these are the oldest larvae down to younger and younger larvae. So here's a very healthy brood pattern of, this means all the larvae got fed and are surviving. Now look at this one. You got larvae of all ages side by side. This means larvae are dying or being cannibalized and then being replaced. Looking at the twist right here, this is looking like possibly European foul brood in this hive. So if you see uneven larval age, do more inspection, figure out what's going on. This would be chalk brood, very distinctive, white, hard pupa behind, and you see this tan colored oval right here. Nothing you can do about chalk brood. Generally clears by itself. If chalk brood has variants, just like COVID does, you're going to see a problem with it for a couple of years, and the bees build up a transgenerational immune inheritance, and it goes away until a new one. So generally, you can either requeen or just wait until the bees deal with it. This is European foul brood, where the larvae turn yellowish and they twist. Then young larvae twist in the cell. Oxytetracycline will usually take care of this pretty quickly. We don't see American foul brood. I haven't seen it in almost 20 years in my county. It used to be our #1 disease. If you're getting good mixture of different colors of pollen, that indicates good nutrition in general. If you only have one color of pollen, you don't know. So if bees are working straight dandelions, a colony will dwindle and collapse if they have only dandelion pollen because they're missing two critical essential amino acids. So not every pollen is nutritionally complete. Then you guys have blackberry up there. We found this last, about a decade ago, this rust fungus really started hitting our blackberry. And the bees in the late summer, September, October, they bring in all this bee bread, which is not pollen. This is all rust fungus spores. And look at the condition of the brood. You have brood dying from it. This was a mystery to us why our colonies were collapsing in the fall. It's from this rust fungus. So if you put in a pollen sub, the bees in a couple of days will have jelly around the larvae and they can recover from this. So keep your eyes open for this fluorescent orange pollen. Orange pollen looking, if you under the microscope, there is zero pollen in these cells. It's 100% rust fungus spores.
Wow.
So the amount of jelly the bees put around the larvae indicates the nutritional status. You can see on that last slide, they're not putting jelly around the larvae because this is terrible nutrition right here. This is a well-fed colony. Second is our larvae have wall-to-wall jelly. When they look like this, you're the best beekeeper in the world. You can do no wrong. This colony is going to be able to out-recruit any problem. So abundant jelly, swimming in jelly. This is good. Now, these larvae are being fed barely enough to stay alive. They're going to emerge, but when they do, they're going to start foraging at an earlier age and will not live as long. So, this would be bees during a dearth period. And then it's up to you whether you feel it's worthwhile feeding them some protein or not. Swimming in jelly, looking good. And dearth again, just barely being fed just enough to stay alive. Okay, now we get to the swarming impulse. So we've gone linear growth stage. The amount of brood, mostly sealed brood now, tops out. And this is the trigger for swarming. We've just shifted from having more larvae, more immatures than adults, to more adults than immatures. And that's a signal to the colony. It's time to swarm. Especially if fresh nectar starts coming down and crowds out the brood nest, there's no more room for young larvae. No room for young larvae, that means no E beta osmine. That tells the colony, wow, either there's something wrong with the queen or we filled the cavity, time for us to swarm. If you're seeing white wax, that means they're out of room, that they don't have enough drawn comb. And this is the only time that you can draw foundation. Now they reproduce when they get the cues that they filled the cavity. So you, as a beekeeper, you can prevent swarming by taking away those cues. I'll talk about it in a second. And your challenge is to build your colonies up for honey production to be really strong, but timing to have them reach top strength just before the honey flow. And you don't want to have your colony set back by swarming. So as long as you have drawn comb that is open right next to or above the brood nest with no honey between it, not below the brood nest, that does not count. It has to be beside the brood nest or above it. And so the queen keep laying, the bees smell E beta osmine and they think they're still in build-up mode and not swarm mode. You can actually reverse the swarm impulse and have them tear down queen cells by simply giving them drawn comb or moving it around. Once you see queen cells being made, there's no preventing it. It doesn't help to cut them out. Time for you to make splits. If you don't make splits, they're going to swarm. And this is colony reproduction happening here. Now, the last thing we want is for our colonies to ever swarm. First thing, it's to reduce honey crop because you lose those bees. It causes nuisances to our neighbors, which we don't want. And if that swarm establishes on somebody's wall or a tree, now you have a competitor for resources out there. Plus, the swarm leaves most of the mites. 70% of the mites are left in the parent hive. So the parent hive is even more worse off with varroa than the swarm is. And if the swarm's established, they become a varroa factory, and later in the season are drifting mites back to your hive. So we do everything we can to avoid our hives from ever swarming. Now, when they swarm, they're full of sealed brood. If you notice on the brood, one adult bee sideways covers 3 cells of sealed brood. So that means if you have a solid frame of sealed brood and it emerges, it's going to emerge onto 3 frames of adult bees. So that's how that colony is able to recover very quickly after it swarms. So that's why you got, when your colonies are in swarm mode and full of sealed brood, understand they're going to explode population very, very quickly if you don't do something. What we do is we kill 3 birds with 1 stone. As soon as they hit swarming mode, we split them. And so we do 3 things. We control swarming, we requeen them because we put in a queen cell, and we do mite management by giving them an oxalic acid dribble. This revolutionized our beekeeping and made all of our beekeeping easier for the rest of the year. Once the main honey flow starts, if the splits haven't built up big enough, just put them back together again and get strong colonies back. But by that time, you've requeened, you controlled swarming, and you controlled your mites. As far as mite control, you get your most bang for the buck by controlling the mites very, very easy early in the season. This is Randy's varroa model, free download or do it on the web. And you plan your mite management. But keep your mite wash level here low for the entire season by getting them low early in the spring. Now we get the main honey flow. You want to reach your maximum colony population right at the beginning of the honey flow. The stronger the colony, proportionally, the more honey they make per bee. So 1 strong colony makes more honey than 2 weaker colonies. Just put the 2 weaker ones together and they'll make more honey. Honey flow begins, you can start shaking nectar here. The bees now shift to full honey storage mode. Then they will down-regulate brood rearing and go into maximum storage. The nectar comes in, the forces the brood nest down, and the mid-age bees will start actually storing nectar in the brood cells when the adult bees emerge. They'll also start producing wax to make new combs if there's room in the hive. So white wax means they're out of storage space. This is the time to draw foundation. There's no other trick in the world for drawing foundation. If they're not making white wax, they're not going to draw foundation. Once they're making white wax, they will fill out foundation very, very quickly in just a couple of days. They'll draw out a foundation. Now there's feedback loops in the hive. I'm not going to go over them that strike a balance between the foragers, the mid-age bees, and the nurse bees, but it's all regulated by the colony itself. When the main honey flow starts here up in Canada, look what happens to brood rearing. Boingo, because they filled the brood nest full of nectar. They don't want any extra mouths to be, so they don't care about any bees that are rearing brood here because there's going to be extra mouths to feed later on. So we trick the bees into storing excess honey by enlarging their cavities so they don't feel like their cavity is filled. Then late summer dries up, no pollen, they go into survival mode. And the attrition exceeds recruitment and they eliminate extra mouths. And this is what happened in Manitoba, Canada here. And that population drops down very quickly here. Come August in my area, this is what we look like. We got fresh honey put on, no pollen stored right here, and the nurses are following the queen, and there's no young larvae. You may see 1,000 eggs right here, but the next day you won't see any young larvae. So the queen's laying eggs every day, and the nurses are following behind her, just consuming them. And this is when varroa can become a big problem. Learn to use my varroa model. It shows the adult bee population, the amount of sealed brood, the amount of sealed brood infested by a mite, the total mite population, and the mite wash count of a half cup of bees. What happens is the mice are increasing at this rate here, but because the amount of bees, adult bees, are going down, your mite wash count suddenly jumps up. So this is from this beekeeper should have been proactive way back here to get the mites down. Again, control varroa early. Mite management usually requires in most environments between 2 and 4 efficacious treatments per year to really keep your mites down and keep the colony healthy all year. For good wintering, you want to get your mite count down prior to this autumn brood ring. So right around here, you want to get it down to as close to 0 as you can. So that last round of brood is not infested by mites or infected by viruses. Once the autumn pollen flow starts, if you have one, the bees will even store pollen below the brood nest as a winter reserve. And you see right now that the bees that are emerging here are the ones that are going to be becoming your winter bees later on. And Heather Madeline published this years ago showing that the bees, here's survival from 100% survival to 0. Bees live for about 35 days if they emerge in late summer. But if they don't engage in brood rearing, then they have a long survival until they engage in brood rearing right here. And then again, about 4 weeks later, they start to drop off and they all die. So what you want to do is first control mites in the fall, and then if necessary, stimulate them with pollen sub to rear that last round of winter brood in October so that they emerge in November to form your winter cluster. If they don't eat it, the pollen sub, just walk away from it. They're not going to make it. So this is fall feeding of pollen sub, going to go inside, and sugar syrup to stimulate brood rearing. So you're creating an artificial nectar flow, artificial pollen flow. Then frost, all the flowers die, and from that point on, they will cease brood rearing and go into the winter cluster. And this is what the bees in Manitoba did after the first frost right here. Emerging workers then come out. They don't smell any young larvae, so they know you're in survival mode. They go gorge on any stored bee bread there is to fill up their fat bodies, and they get turned into the winter bees with all their fat bodies stored here. Store as much food as they can in their bodies because it does not ferment in their bodies and they not degrade. It degrades as bee bread. So foragers don't have it, and fat bodies, they want to reduce their weight. So your nurse and winter bees have heavy fat bodies. So winter bees are simply nurses in arrested development. The fall turnover is when all those bees that are doing their last flying here fly away and die and just leave those young bees that have not flown to become the winter cluster. As long as they don't fly, they're almost immortal. The rule of thumb used to be take your winter losses in the fall. So if you want to have high winter survival rate, go through your hives in the fall and just combine or cull any of the poor ones. What we do is we do not combine a weak colony with a strong colony because we don't know why that weak colony is weak. But we'll stack the weak colonies up 2, 3, 4 high when their clusters combine, they often turn into a healthy, strong colony. So we combine all of our weak or sick looking colonies together, leaving nothing but strong colonies to go into the winter. And the bees form the winter cluster. Looks like a tight ball, but they have a insulating shell of bees around the outside. So if you give them a puff of smoke, this tropical environment in the middle, they move away, but these bees outside are too cold to move. And they keep that shell usually around 55 degrees on the outside, their head sticking in, airtight inside. Carbon dioxide level goes way up, oxygen level goes way down. These bees in the middle are thirsty. These bees here get plenty of water from condensation. Most of the heating is done by these bees that keep at this just above chill coma temperature, right around 50 to 60, 55 degrees right around here. Bees like to seal off the hive during winter. They do best with minimal ventilation and just a few, one or more small bottom entrances. You want to insulate the top. If you see melting snow on the top, that means you're losing heat there, and you have water dripping on the cluster from the lid. So insulation on the top is way more important than insulation on the side. Now I shifted the scale here to show this minimal attrition of the winter bees over the winter. They just hold the fort until the next pollen flow. Now in the winter, everywhere we study, there is some initiation of brood rearing during the winter, on and off in the occasional in the colonies. We're not quite sure why that is, but it may be in order to do water balance or simply to maintain the population. Lloyd Harris says if they didn't do winter brood rearing, a small amount, that they'd have half the size of the colonies when they came out of winter. So here's bees doing winter brood rearing in colony of mine. No pollen reserves to speak of. It takes about 3 bees body reserves to rear one larva, but they'll do some during the winter. You can do late winter brood rearing here in California. You can feed right during January when it's quite cold, and the bees will respond to that and rear up. Then the first pollen comes in, first tree pollens. Same thing here. Brood rearing starts again. Here I am in the foothills, and the cycle starts again. Yeah, that's it. So let's see. Yep, keep young, vigorous queens, provide good nutrition, control varroa all year long, be proactive, minimize the toxins in the hive from outside or things that you put in, and manage proactively rather than reactively. And I'm open for questions.
Wow. Thank you, Randy. Let me first take questions from the room. Anybody want to come up?
What is? Let me get over. Okay. There we go. Stop share. There we go.
All right. Who wants to be the first question?
Information overload.
We did have a question online, and it was answered by Dewey. Is there a good resource to figure out which flowers are blooming when in the Portland area? And Glenn at Bridgetown Bees has a month's what's in bloom on his website.
Wonderful. Yeah, that's very valuable.
And I take note that you said the bee club should provide that, and I will make an action item for myself for that.
Okay, I see the question about dribble rather than OAV. OAV won't work. Dribble is more efficacious than vaporization, but either one would work. Whoops, how did wild bees exist? I guess I could open the chat here.
How do wild bees exist without pollen substitute and varroa management plans? Okay,
without pollen substitute, they don't exist in areas where there is too much of a pollen dearth. So that honeybees don't exist everywhere. They have to have adequate food coming in to put on reserves to make it through the winter. There's unless you're an almond pollinator, like in my area, we feed our bees in the fall with a lot of pollen sub to build up for almond pollination. My suggestions to the hobby beekeepers around here is don't do that, because that just means you're going to have early swarming from those big colonies, you're better off not feeding pollen sub if they have some brood rearing going in the fall. Start out with a smaller cluster going into winter, and then you're not going to have early swarming. So depends upon what your objective is. Anytime anybody asks me a question about bees management, I say, what's your objective? And then I work backwards from their objective. There's no one rule for everybody. And as far as varroa management, there are bees in many parts of the world of honeybees that have, through natural selection of survival of those that can handle varroa, have resistance to the mite, and that's there are beekeepers in many parts of the world using those bees, working with nature that way.
I had a question.
Go ahead.
I was wondering, have you done any studies on whether or not you can artificially stimulate the bees using dry pollen substitute to make that trigger happen where they believe that there's actual pollen flow coming in? Or is
Yeah,
it just,
yeah,
or is it just like,
I've done a lot of research on that.
is it possible to do that?
It is, but it's not consistent. So here's what I would suggest that you do. Put out your bucket of dry pollen sub, and you'll see the bees in a few minutes when they start working. They'll work it very, very vigorously. And all the bees, they hover in there, they build up electrostatic charge in their bodies. That pollen sub jumps out and clings to their bodies. So they get very light colored. So you can see the bees that are exiting that bucket will be very light colored. Now walk around your apiary and look at the entrance of every hive for light colored bees coming in. And you're going to walk by, say you have 24 hives there. About every maybe sixth hive or so, you go, wow, every bee coming back has pollen sub on it. And you go to the other ones and go, wow, there's none coming in here. So yes, some hives get very stimulated by it, but unless you feed them sugar syrup, they don't really produce the jelly. So what I found, I've used fluorescent tracers to see the pollen sub coming in, which bees get it, where they put it, how they use it, and what we found is just it's inconsistent from hive to hive. If you want to manage your apiary with the bees being uniform, which most commercial beekeepers want to do, you're way better off feeding pollen sub as a patty right in the middle of the brood nest between the brood chambers. The other thing is quite a few of us have found dry feeding pollen sub in the fall. We have really bad experiences with colony survival. And we don't really know why that is. That'd be a very good research project. So theoretically, dry feeding pollen sub can work. You can get a lot of pollen in. You can get as much into the bees by them gather themselves as you can by feeding them pollen sub as patty, but it's much more irregular from hive to hive.
So the patty itself, if you fed them protein in a patty form, it would do the same thing essentially then, even though the act of foraging isn't actually happening, they're just consuming it within their hive.
Right.
Okay.
And again, consuming it, when you say they're consuming, who's consuming it and where in the hive? Both of those things are important. It's got to be the nurse bees consuming it. It's not the older bees that are just sucking the syrup out of it and carrying it outside. The closer it is to the nurse bees, the better they respond to it. So even if there's a study that showing if you put even natural pollen patties on the top bars, how far you move them away from the nurse bees, there's a huge dropout. Once the drop off in nurse response, once it's over like an inch away from the nurse bees. So when you feed pollen sub, make sure you're putting it right in the middle of the brood nest. We like to squeeze it in between the combs.
Now we've got a bunch of questions.
Oh, they're waking up.
Chris asks, when weather halts your feeding and varroa management schedule, just wait it out and continue with your original plans.
No,
Just
wait.
the schedule out?
No. It's called foul weather gear. So what I tell people is the only thing the weather does is it changes how we dress. Okay, we do the same thing, our same plan to the bees, independent of the weather. If it's raining, we just wear foul weather gear. But if the bees need food, if they need varroa management, no, but my sons, they've been out the last 2 days during rain in the foul weather gear, working all day, taking care of the bees, doing mite washes and varroa management.
Hi, this is Chris. Can I just follow up with that?
Yeah.
Because I like where you're thinking. We have a saying in German, there's no bad weather, just bad clothing.
Hmm.
But being a new beekeeper, I was always told, oh no, it's cloudy. Oh no, it's raining. Don't open that hive. So that theory goes out, or that goes out the window in
Yeah.
this case.
A quick hive opening. We make nukes when it is snowing, and they do fine. But
Okay,
we make our nukes very quickly. They're only open for the hives are open for seconds, and we split a double deep into 4 to 5 nukes, close them back up, and they're fine.
awesome. Thank you.
Bet.
Tammy asks, what if you put the dry pollen in your sugar water?
It all settles to the bottom and makes a real mess. So that was the original design for Mega Bee, developed by Gordy Wardell, to grind it up really, really fine so it would stay suspended, but it did not do a good job of staying suspended, and he dropped off on using it, selling it with that, promoting it that way. If you could get it suspended somehow, yeah, it works fine, but it was too much problem with it.
Jeremiah asks, is feeding colonies heated honey recovered from processed cappings worth it, or does it damage them?
Depends on how much you heat it. If you heat it, and the problem would be hydroxymethylfurfural. So any sugary substance that is acidic when you heat it up creates this hydroxymethylfurfural, or HMF is what the abbreviation. So like a jam, if you make jam at home, it's got a ton of hydroxymethylfurfural. It's fine for humans, but it would be poisonous to bees. So if you heat it hot, it can cause a problem for the honeybees. So it depends upon how much you're heating it.
Our member Jessica's got a question for you.
We had one that came in on Facebook earlier today. They wondered if you could, I don't know if Dan's on, to make some comments about the 2 new mite treatments that have been approved by the EPA, but are not yet approved by any of the states.
Okay, so one is the double-stranded RNA one from Greenlight Biosciences, and could very well work. I'm actually working with double-stranded RNA with another group right now for an antiviral product, and we're picking up from where we started back in 2008. So that's promising. The double-stranded RNA breaks down very quickly in the environment. The one we're using are all totally natural sequences that you would find within the bees. The other one is somewhat artificial, but it breaks down very quickly, so it's not a concern for food or anything like that. I'm not sure about what the other one is. You're not talking about Broxand, are you?
He didn't say, I don't know.
Okay, so Broxand is the other one, the oxalic acid strips, and actually I was setting up an experiment with them minutes before I got logged into this presentation. I had some interesting findings with that, but that can work well in hives.
Okay, Gil has a question. Is there a resource to determine whether pollen or nectar are healthy rather than incomplete depending on the source?
Yeah, you open your comb and you look at the larvae, see how much jelly there is. If they got lots of jelly, then it's nutritionally complete. If there's not much jelly, then it's not.
Anonymous says, can you please explain the OA dribble process?
Well, there's lots of information on my website. What I suggest is the easiest way to put it on is you get a 250 milliliter wash bottle, lab wash bottle. They call them tattoo wash bottles also. You cut one tiny bit of millimeter off the tip of the end, and with a gentle squeeze, that puts out 5 milliliters per second. And so it takes you 10 seconds to treat 10 combs of bees. You squirt it not onto the wood, but onto the interspaces over the bees. Again, look at my website. There's lots of information on, just look for the word dribble.
Excellent. Leah asked what are successful Portland beekeepers doing right now with their bees, and James has answered feeding 1-to-1 syrup, transitioning to 1 to 1.3 this week. think
so-
1 gallon water to 10 pounds sugar.
Yeah, so typically as the weather cools, if you're not done feeding, you're gonna go for a higher concentration of sugar, typically like a 2-to-1 for winter storage. So 1-to-1 is for stimulation, 2-to-1, 2 parts sugar to 1 part water is for stores.
Excellent. Anybody else want to jump in?
Yeah, what causes dysentery and what can you treat, or is it possible to treat for dysentery?
I don't know if there's anything treatment. Most of the time, dysentery is due to too much water in the gut. The bees have to get rid of it. So if they're um, confined by weather in the colony and they're eating a whole lot of pollen, they can get dysentery. Sometimes you get it from poorly digested foods, and that could be a pollen sub that has some poorly digested materials in it, or possibly from certain flowers. Usually it comes and goes pretty quickly. Unless it persists, it's not cause for any kind of alarm. Only if it persists or they start having dysentery within the hive, but I've never heard of any treatment that you can use for it. When do you stop the 2-to-1 syrup? Well, why are you feeding 2-to-1 syrup? If you're feeding it to put on reserve for the winter when the colony is heavy enough. We like our colonies to, if you grab the front cleat of the hive and to tip it up, it should weigh about 65 pounds. That means you have 130 pounds in a double deep, and that they winter well on about that much. And the Demery method, it's always seemed excessively complicated to me. Theoretically, it works great. There's nothing wrong. It can really work. Just one thing I've learned with beekeepers worldwide, you can tell them the simplest, easiest way to do everything, and they will immediately figure out a way to make it more complicated, more expensive, more time consuming. So that's just the nature of beekeepers.
Are there any updates on research you're doing with thymol-based interventions?
Yeah, I got several of them going. I'm the Thymol blocks. I did some trials again with them this year to duplicate my findings last year. I found out if there's much shade on the hives, that if the blocks applied under the cover, it has to be hot outside. I tried some with white covers intentionally compared to dark covers. It did not work well with the light covers. If in yards with shade, it did not work well. I'm working now with trying it. Actually, I'm going to be applying some tomorrow within the brood nest, between the brood chambers, and I'm trying different placements of them. So yeah, the answer is yes, I am involved in thymol research, and I will be publishing that too.
And one more question. How's your health, Randy, aside from the cold? Are we ever going to see you in person again in Oregon?
Oh yeah, I'd be happy to come up there sometime. No, my health is great. I had that tumor in my tongue. I do have scar tissue in my tongue, so it's a little bit harder to articulate words. I have to slow down. But other than that, everything's doing great. I still work my ass off. I still do 14-hour days, 7 days a week. One of these years, I'm going to have to slow down, but I don't know when that's going to be.
Got to put your kids to work. Okay, Randy, I think we've taken up a good portion of your time, and I really
Okay.
appreciate.
All right. Well, enjoyed talking to y'all. Great questions, everybody. There's always so many questions, and I'll tell you right now, I've been keeping bees all my life. I'm going to die with more questions than I started with. So, yeah, more research I do, the more questions I have. But I find that fascinating and challenging. All right, happy beekeeping, everybody. Hope you have a great season.
Thank you very much.
Thank you.
I've got a couple announcements about upcoming events. October 5th, we have Learning Apiary, and that's the last meetup of the season. So please come and talk to Jana if you want to RSVP. October 24th through the 26th is the Oregon State Beekeeper Association Conference in Bend. I'll see you there with a big check for Oregon State beekeepers. And the 25th is Gather and Blather at Paladins League. Someone besides myself will take it over. It's a great spot. And November 5th, Hannah Lucas from OSU Honeybee Lab is going to be speaking then. So thank you to almost 90 participants today, which I think is a record for us. So thanks again, everybody. And we'll see you next month or on Saturday or Sunday.